So hello everyone, welcome to AnalytixCloud. This is your host Gaurav, and today we are starting up with the second part of our video of the series SQL, where we will be talking about Introduction to Heap. Right? In our first part, we just spoke about how do SQL indexes really work. So let me tell you, this is a very important topic that comes in on like mostly in all of the interviews, and if you know the concepts of this indexes in the backend, that would be a really advantage for you in an interview. Okay, so if you have not watched our first part, I would request you to have a look to the first part before, where we have talked about what is clustered index, what is non-clustered index, and how exactly is clustered index created, and how do we create non-clustered indexes, and what is the performance difference that we see in those two indexes, right? So now coming to the second part, here we will be talking about what exactly is a heap or a heap table. Okay, so let us just start a video. For those people who have not subscribed to us yet, I would request you to please subscribe so that we can come up with more videos. So that will be a motivation for us, and also you can just put in your comments if you want to come up with some other video as well. Okay, so let us just start our today's session. So I'll go to my whiteboard, and so let's say if I'll go here. So if you remember last day, like the part 1, we discussed about, as I mentioned, cluster index and non-cluster index. So we are into the same whiteboard, and we will be starting with, so if you'll see here, this is what we discussed in a part 1, where we have a cluster index. We will be having index rows, and then we will be having data rows, so from where it will be fetching the data. Similarly, for the non-cluster index, we will be having key values and the row locator. So now let us just come to our second most important topic, which is heap. Okay, so what is heap, first of all? Okay, so if I'll just, so let's say if we have a table, okay, if we have a table, let's say we have supplier id, we have supplier name, we have email, let's say, and let's say we have department. Okay, so we have these 4 columns in one of our dimension tables. Okay, so as you know, in probably in each table there will be one primary key, not necessarily, but we will be defining a primary key if required, so which will uniquely identifies that table. Correct. So in this case, in our table, the most eligible key is supplier id, which will be non-unique, and hence it will be a primary key. Correct. And as we discussed in our last video, like if we are creating a primary key on the column, then by default a clustered index will be created. As soon as the cluster index gets created, that means data will be stored physically in sorted fashion, right? So what exactly does this mean? Let's say if I am inserting the value into the supplier id table using insert into table values, and let's say I am first inserting of value 1, and let's say a name, and say I am giving some email, and then similarly I am giving some department, right? And then similarly, let's say now I am inserting the third id, which is for b. Now I am giving the email and the department. When I will be running a query on top of this, let's say if I'll be writing select star from supplier table, I will always get the data in form of ascending order for the supplier id column. So we first will get the record for first, and then we'll get 2, then we'll get 3, and so on, because we have created cluster index on this supplier id column, right? And since we are arranging these records physically in an order fashion, and that's the reason we cannot have more than one clustered index in a column, right? Because we cannot physically store the data in sorted fashion based on 2 columns, right? You could only have one column. If you want to have basically if you want to improve the performances, then basically we will have to go for the other index, which is non-clustered index, which could be either in any of the other columns which might be used in the joins that you are doing. Correct. So now let us come back to our topic where we were discussing about the heap. So if in a table there is no primary key, okay, let's say in this table itself, I will take an example. I don't have any primary key, let's say. So if I do not have any primary key, that means I won't have any clustered index, and there won't be any data that will be in a sorted fashion, right? So those tables which do not have any primary keys are called as heap or heap tables. Okay, now even though you might have a non-clustered index on supplier name, either you might have non-clustered index on email, or you might have non-clustered index on department, even though either you have or you don't have, the only requirement is there should not be any primary key column in the table, and that table is called as a heap table. Okay, I hope I am clear. So now let's just come to the second part. So let's say if we have created a table which is a heap table by not defining a primary key. So let me go to the SQL Server Management Studio. Okay, so I'll just remove everything and I'll just start from the scratch so that you can understand more easily. So I'm just dropping the table that I have and I'll create it for you. So let's say I'm creating table supplier. Okay, let's say we have supplier ID. I'll make it as int. We have supplier name. Let's keep it as varchar 20. Then we'll have supplier, not supplier, we can have just an email. Let's say nvarchar 20. Then we can have department. Let's say I'll make it as varchar 10. Okay, so this is how we define our table. So let me just execute it. So we have created a table where we do not have any of the indexes. How can we check that? We have a default stored procedure which is called as sp underscore help index, and you can give your table name which is supplier, and you can execute this. So if you'll see here, it's saying that the object supplier does not have any indexes, correct? So we are good with the table, and this table is a heap table, right? Without any non-clustered indexes as well. So now let us just try to insert some value here. Insert into supplier. Let us give some values. Let be supplier ID is 1. Let's say supplier name is shell. I'll give some shell 101 at the rate shell.com. Okay, then I give department, let's say oil. Okay, so similar way, let us just insert few more values. This is just the sample values that I am placing in just for making you understand. So let's say 02, 03, 04, then 104, 103, 102. Okay, now let me run this. Okay, so now we have a supplier table and we have 4 records in them. Let me just run the select query. Okay, so as you can see, we have 4 records that is present, and this table does not have any of those indexes. So now let me go back here and let me ask you one question. Okay, so what we have done here in this case, we are running select star. Let's say I'll just give another query. Let's say I am running select star from supplier table, okay, where supplier name is equals to shell 101. Now tell me, since this is a heap, how exactly the execution plan will happen? Like if the SQL Server has 3 options, right? Either it can go for an index scan, or it can go for index seek, or it can go for table scan. So what do you think, which approach will SQL Server take? So let's say first is this, second is this, and third is this. Okay, so let us just look into this practically. So I'll go back to SQL Server Management Studio. I'll just write this query where supplier name equals to shell. It is 02 here in this, so I'll just keep 02. Let's just run this. I have enabled this actual execution plan, okay, so that we can see the execution plan once it runs. So here now you could see it has returned that record which is shell 02. Now let us go to the execution plan, and here if we could see it is table scan that SQL Server took, right? And here if you'll see in the first, second, third, fourth, fifth, sixth record, the actual number of rows that is read is 4, right? So we have inserted 4 records in this table, and actual number of rows for all execution came as 1. That means the output that was generated contains 1 record, correct? So this answers our question that if we are running any query on a heap table where there is no indexes, uh, no non-cluster indexes as such, then the approach that SQL Server will take is table scan, right? And let us just go to the select and try to see what is the estimated subtree cost. So the estimated subtree cost here is 0.00328664, which is quite good actually. So what I'll do is I'll just note it down here for the reference, 0.00328664. Okay. Okay, I'll just reconfirm, 0.00328664. Okay, so this is the time that this query took when we were running it as a table scan. Okay, now let us just do one more thing. Okay, I'll just give you one more example in this case. So let's say now let us just insert few more values. Let's say I'll give it as 6. Let's say I'll give it as 5. Shell 05 0. Let's say I'll give it as this one as 6, and I'll give it 0 or 5. Okay, let's say 5, and I'll give it as 6. Okay, now let me run this. Okay, so we have inserted few more records here, correct? Now if I'll run this, you could see we have 6 records now inserted, the 4 which we inserted earlier, 2 records which we inserted later. Now here if you will see in the supplier ID column, after 1, 2, 3 and 4, the record that was inserted was 6, right? And after that the supplier ID that came was 5th. So this is based on the order that we entered, correct? That means the supplier ID is not sorted in any fashion, in any ascending form, right? And that's what we discussed. Like if it is an if it is a clustered index, then it would have been sorted as a ascending order. But in this case the physical order of rows is not guaranteed on the way we insert. Basically it might change dynamically, hence we should always use order by when we are running any query on the heap. Okay, so that is the one point. Now let us just do one thing. Probably we have already captured this cost. Now let us just try to create a non-clustered index. Okay, so what we can do is we can just write create non-clustered index. Okay, let us just give it as index supplier name. Okay, on supplier, and the column is supplier name. Okay, so what I've done is I am creating a non-clustered index on this column. Okay, now if I have created non-clustered index on this column. So definitely now the approach that a SQL execution plan will take should be different. Now let us just try to run the same query and see after we have applied non-clustered index on the table. Okay, so here if you'll see we have the output of this record, and probably if I'll go to the execution plan, okay, now we can see still we are seeing that SQL execution plan has taken the table scan to return the output, right? Here we can see the actual number of rows read is 6, actual number of rows for all execution is 1 because one output is generated and it has read 6 records. But still, instead of going to either index scan or index seek, the SQL Server has taken the table scan only. Now, if I'll come to the estimated subtree cost, it is 0.0032886. So, if I'll just note down here, 32866. Okay. So, if you'll see 886, sorry, I'll just okay, so if you see the difference here, actually this has taken a very like microseconds, a few more time than this, though anyways both of them took index scan, sorry, though table scan, so that to generate the output. That means what we can say here is, even though we are creating non-clustered index on the columns, and if we are running the query on those columns, still SQL is server is using non basically table scan to generate the output, correct? Because so that means it is not necessarily that table scan is always bad, correct? Now let's say we'll do one thing here. Instead of uh, going to a table scan, let us just tell SQL Server to use our index that we have created, the non-clustered index. So let's say if what I'll do is I'll just write select star from supplier, okay, with the index that we have created, which is the AX underscore name, okay, where supplier name equals to shell02. Okay, now we have explicitly saying SQL Server to use our indexes in order to run the query, and let us just see the output now. Okay, we have the output. Let us just go to the execution plan. So now you could see it has took index seek approach, which is non-clustered index seek, in order to generate the output, correct? Because we have explicitly mentioned that go with this in basically non-clustered key that we have created. And here if you see the actual number of rows that is read is 1 because we are going through this index, and then actual number of rows that is for all the executions are also 1 since the output is 1, correct? And then it is using some row id lookup, and then based on the inner join, and it is finally giving us this select, which is taking time, which is 0.0065704. If I'll just note it down here, I'll just reconfirm 0.0065704. So here you could see, even though we have created a non-clustered index on this column, and if we are using this index, still the query time that it is taking more than those conditions where we do not have any keys at all, where we do not have, let's say, uh, not a like not just only the having any keys, even though we are having keys, then also since the SQL server is not using this index and it is taking table scan, it is having much higher performance than this case where we are taking with the non-clustered index. So that gives us a really very important concept here, that it's not necessarily that table scan is always bad in performance, right? Here if you could see, table scan is performing better than index seek. right? So this is a very important concept that many people doesn't know, and you must uh, ensure that you should convey this to your interviewer once they are asking any question with respect to the with index. Okay, so now let us just uh, come to the conclusion. Okay, so if I'll go back here, so what are things that you really need in order to create a heap? Okay, so in order to create a heap, first what you have to do is either you create a table without clustered index or without primary key or any clustered index, or if there is any index on the table, just drop that index. So in this two cases it will be heap, correct? Now, if there is a heap and you want to remove the heap, then it's very simple. Just create the index, create cluster index. Okay, so that's how you basically create heap and remove heap. Now let us try to understand what is the usage of heap, right? So heap can be used for those conditions where we have, let's say, a staging table, right? Let's say you want to do a data load from source to target, and in order to do the data load from source to target, let's say you have some staging table first. So first what you will do is from source you will load the data to staging, and then from staging you will load the data to target. So in this staging layer, instead of creating a table and giving the primary keys and non-cluster index and all those stuff, instead you can just have it as a heap table. So what will happen if you will have as a heap table anyways, without the indexes, the record insertion will be faster. Also the query basically the query that you will be fetching, that also will be faster. But also it depends on different scenarios. Like let's say it will be useful when, let's say, either we have a table which is having few rows, right? Let's say table with few rows, which we just saw, correct? Then if we want to do an unordered insert operations, correct, then it could also be, there could also be a case, let's say, when data is always accessed from a non-clustered index. Let's say all the data that you are accessing are using non-clustered index columns, right? So in those cases you could just remove those clustered and non-clustered index, and we can use a heap in order to increase the query execution time, right? So that's it for today video, and in our next video we will be talking about the execution plan, like basically which we have, like let's say we have RID lookup and then we have key lookup. So the, if you could see, the query that we ran just gave us RID lookup as well. So next video we will be discussing on the same. Till then, have a good weekend, and if you have not subscribed us, please, I would request you to please subscribe, so that will help us to bring more videos to you guys. Okay, thank you, have a nice day, bye.